Hello, my name is Krenc, and this is joint work with Beverly and Georgios Smaragdakis, and it's about the routing message impact of BGP communities. Over the past 10 years, the number of BGP communities and the number of autonomous systems that use communities has increased dramatically. Communities are used to annotate routes, to signal information or instructions to neighboring ASes. In this simplified example, ASZ announces a route with a community attached towards ASY. However, communities are not standardized in their meaning, so ASY in this example may not necessarily understand the community. Since the community attribute is a transitive and optional attribute, ASY can simply ignore the community and export the route to ASX. Or it can filter the community prior to exporting the route. Also, it can filter the community when importing the route, so the community propagation stops at the ingress of ASY. In fact, whether an AS filters BGP communities or not has a significant impact on the routing system. In this work, we show that missing or ineffective filtering of communities can lead to an increase of unnecessary announcements. We consider announcements unnecessary if they do not update the AS path attribute while the community attribute still may change. So in order to identify unnecessary announcements, we use historic routing data spanning 10 years from the route collector project's rapid route views. And we track changes in the AS path and community attributes per BGP session and prefix, so we don't mix unrelated announcements. Looking at more than 1 billion consecutive announcements on a single day in March 2020, to our surprise we find that around 50% show no path change. Further, half of those announcements change the community attribute, while the other half does not change the community, which we refer to as duplicates. Peer ASes provide us with ground truth data as they send updates to the BGP collectors that we use in this work. In this plot we show how peer ASes perceive unnecessary announcements. On the x-axis we show the number of consecutive announcements just updating the community but not the path. On the y-axis we show the number of duplicates where neither of the two attributes change. Out of 451 peers, around 2/3 sent both duplicates as well as community updates, while 1/3 sent duplicates only. Less than 1% of the peers sent no unnecessary announcements at all. Furthermore, there's not a single peer that sends community updates without duplicates, implying that when community changes occur, duplicates seem to be a constant byproduct. As a side note, we also use AS types to label the individual peers, but we find no correlation with the announcement behavior. We next show the conditions that can lead to unnecessary announcements. In the depicted topology, Z1 originates a prefix and is reachable via Y2, which is the default, and Y3, which is the backup route. In order to artificially induce updates, we disable the link between Y1 and Y2, and we monitor the resulting updates at X1 and C1. We use 10 different BGP implementations from 7 vendors and routing daemon projects to perform 4 different experiments. In the following, we briefly summarize the results. For more information, please have a look at the paper. In the first experiment, when no communities are used, we find that 8 out of 10 implementations generate duplicates due to an X-top change. In the second experiment, we add communities and we find that 8 out of 10 implementations generate updates due to a change in the community attribute only due to an implicit withdrawal. In the third experiment, we find that if communities are filtered at egress, 7 out of 10 implementations generate duplicates. Finally, when communities are filtered at ingress, none of the implementations send updates. We conclude that unnecessary announcements caused by changing communities can be avoided when communities are filtered at ingress. Going back to our observations in the wild, we show how PAS 20205 generates unnecessary announcements due to missing filtering. We use a write beacon prefix that is announced every 4 hours starting at 12 AM UTC and withdrawn every 4 hours starting at 2 AM UTC. We note that all communities in this example are geolocation communities set by AS3356. The plot shows the cumulative sum of announcements over a full day in March 2020. At each withdrawal interval, we observe an initial path and community change indicated by the dark blue line, followed by one or more community updates, dark red line, and concluded by a withdrawal, yellow vertical line. Those announcements are the result of path exploration or path hunting, which is an inherent problem of distance vector algorithms such as BGP. We zoom into one of the withdrawal intervals and show a simplified version of the events. When the AS path becomes active, AS33506 sends its first candidate, the triangle route, to AS20205, which is forwarded to the route collector. When the triangle route is withdrawn at AS3356, it sends the next candidate, the square route. And this continues until AS3356 has no more candidates and concludes with an explicit withdrawal. Unnecessary announcements come with some implications. Given the information hiding character of BGP, we want to know how much information, encoded in community attributes, is revealed during withdrawal phases of beacon prefixes. And we find that on a single day, around 60% of unique community attributes are revealed exclusively during withdrawals. And this is true for the past 10 years. We argue that communities revealed in such a way have no significance to other ASes because the destination is not reachable anyways. Another aspect to consider is the increase of routing messages and the subsequent inflation of archived routing data caused by unnecessary announcements. By analyzing more than 250k update files from the collectors that we use in this work, we find that on average at least 20% of update messages can be saved. This is a lower bound. As part of our validation process, we have published and shared our results with network operators and routing software developers via various mailing lists and private channels. Overall, we have received affirmative and supportive feedback, and our findings help to identify a source of duplicates in a current popular BGP implementation. Last but not least, we publish the router configurations and tools to recreate our measurements on the displayed website. Thank you.